Okay. All right. Are you guys able to see the screen?
Yeah.
Excellent. I have to do this. All right. So good afternoon and good evening and good morning to wherever people are tuned into this tribology. This
I can hear you now, Deepak.
Yeah, even I'm not able to hear Deepak.
That is true. I can't. Actually, Deepak is unmute. I don't know why.
Yeah, right. You're right.
can you hear me now?
Yes.
Yeah.
Excellent. All right. So thank you for your patience. And today's discussion it's on transportation sector. So the lubrication challenges in the transportation sector. And we had 3 previous sessions on various topics related to lubrication challenges, starting with nano lubricants. And then we had, can you hear me, Sergio?
Yeah, yeah.
Yes.
Absolutely.
Yeah. So on nano lubricants, and then we had metal forming, and now we are talking about transportation sector. All these events are proudly sponsored by MOOHA. It is a digital assistant in tribology. It's designed for scientists in tribology labs and teachers in the classroom. So I'll skip through that. Transportation versus mobility. They both are not the same. Transportation is an act of taking and moving a person or staying from place A to place B, whereas mobility is the ability to move people from place A to B, which is derived or which is driven by few key elements, because the ability at the center means sustainability and, for example, a flexibility. So the mobility equals flexibility means you're talking about the ride sharing elements, and the mobility means sustainability means we are talking about a reduction in carbon emission, having more greener environment. It also means the trends would change compared to conventional way of transportation. As you see in this graph, we are moving towards the hybrid electric vehicles, or completely battery powered electric vehicles here. So mobility means the ability to freely move around, from whatever the place A to place B, which includes flexibility, accessibility, and sustainability, which basically questions the traditional, the conventional way of transportation, and that will be the theme of discussion today. Meaning, what happens when you transform from transportation to mobility is it has a big impact on the entire value chain in the automotive sector. As you see in this graph here, the volume of lubricants would increase until 2030, and it starts to decrease after 2030. And one of the major reasons for this is introduction or adoption of electric vehicles here. And the same.
Sorry, Deepak.
Deepak,
we cannot see the. Yeah, we cannot see the slides. We just see the first one.
Oh, can you see the?
Yeah, we stay still on the transportation versus mobility.
Yeah.
All right.
You are not maybe in the presentation mode.
Can you see now? No.
No. Just fix a slide. Second one.
Let me check. Let me share again.
But everything was very interesting.
Now?
Now, yeah, just move forward. Yeah, now yes, they are uploading.
Okay, thank you very much. Please highlight if you can't see the slides. All right, so let me start again. So again, transportation versus mobility. Mobility is all about ability to freely move person or things from place A to place B, and which includes certain value drivers. Number one, flexibility, and that's been provided by car share. That basically transforms transportation to mobility. The second one is sustainability. Mobility means sustainability. This is the perception we have, and it means adoption to more cleaner energy-driven transportation technologies. Here it comes. The ICE is ICL, internal combustion engines. HEV is hybrid electric vehicles. BEV is battery electric vehicles. As you see here, by 2030, you will be seeing a significant portion of our road transportation will be driven by hybrid and battery powers. So what this means to lubricant industry, what this means to bearing industry is a big question. So if you look at the lubricant industry, this is the bar graph, this is a survey done by McKinsey. The volume of the lubricants would increase to 2030, and that's basically, we call it as a threshold. At that point, there is a significant adoption to alternatives to the internal combustion engine, and the volume of the lubricants used goes down. That's from 16.9 to 15.9. And same thing happens in the similar things would happen in the bearing industry as well, where the number of bearings required in the powertrain would go down when you switch from internal combustion engine to electrical vehicle engine. There is a lot of technology and policy aspects to this transformation from transportation to mobility. Right? To discuss these technology and policy aspects in this transition from transportation to mobility, we have two keynote speakers on this platform. One is Dr. Ramakumar, the first one, who's a director, research and development, a board member of Indian Oil Corporation Limited, who has more than 30 years of experience in tribology, a well-known figure in Indian Tribology Society and worldwide. His topic is lubrication imperatives for mobility sector. He will touch upon those elements, those challenges that have been posed during this transition from transportation to mobility. And he will talk about lubrication. And the second speaker we have is Dr. Sergio Domingo, who has 10+ years of experience in bearing design. He has gone through extensive research and implemented design thinking in transportation. He's a director of research and development and innovation from Fersa Bearings in Spain. His topic is bearings in electric vehicles, still there. Very interesting title, challenging. So we are looking forward to these talks right now. And the first speaker would be Dr. Ramakumar, who will touch upon the imperatives for mobility sector. He has 35 to 40 minutes. After this, Dr. Sergio will continue will have his presentation, and we will move forward with few discussions and interaction. So I will stop sharing the screen, Dr. Ramakumar, and you can share the screen and then take over from here. You have to unmute your mic, Dr. Ramakumar. Yeah. If you click on the share screen below, and you can choose the slides.
Yeah, I'm trying to do that, but it is saying that host disabled participant screen sharing. So you have to enable me.
Can you try now, Dr. Ramakumar?
Yeah. Yeah.
Excellent. We can see the slides.
Yeah, is it in full screen?
It is in full screen.
Okay, so
Yes.
thank you very much, Dr. Deepak, for giving me this opportunity to speak about lubrication imperatives for mobility sector. In fact, this is the chosen field of research for me for my first 25 years of my career as a researcher in Indian Oil R&D Center. But beyond that, I have diversified into many other areas which my center pursues. So it gives me additional pleasure that of late nobody asked me to speak on lubrication because they asked me some other areas which I've been pursuing. So I'm more than particularly pleased to revisit a subject of my own interest and of my research career for almost 25 years. So I have organized my talk of next 30 minutes in these kind of heads. I would be talking about regulatory imperatives because mobility sector is all about regulation and compliance with regulations in whichever geography that you're in. And am I audible?
Very
Yes,
clear, very clear.
yes.
Yeah, okay.
Yeah.
So
Yes.
then since I belong to India, I would be talking about the BS6, which is nothing but Euro 6 emission regulations and the BS6 compliant lubricant chemistry. And I would be particularly focusing my talk on fuel economy because many regulatory compliances, whether it is climate change, whether it is ambient air quality, they are all at the center of all these themes is how fuel efficient is your vehicles. So in this talk, I would be just giving a glimpse of how mobility lubricants or the automotive lubricants, to be precise, can contribute to this fuel economy, overall fuel economy of the vehicles, and thereby they would be enabling the mobility segment to meet the climate challenges or climate imperatives. I would be talking about hydrodynamic regime, lubricants in hydrodynamic regime, boundary regime, talking about particularly passenger car motor oils, heavy duty diesel lubricants, tractor, motorcycle segments. And of course, I'll briefly touch upon some of the challenges, lubrication challenges as a formulator that we face when we formulate the transmission oils for electric cars. So moving on with my presentation, first let us see what kind of regulatory imperatives that we are talking when we talk about mobility segment. Most of the mobility segment all over the world, not only in India, are governed by three major imperatives. Improvement of air quality. Most of the emission legislations are finally the end deliverable is air quality improvement. Then climate change, lot of greenhouse gas emissions, and so climate change is another imperative. Zero emission travel, when more and more urbanization is there, mobility has become, by the way, I liked your definition of difference between transportation and mobility. So when mobility becomes more and more pronounced for urbanized civilizations, uh, targeting and achieving zero emission travel is one of the key drivers in the sustainability uh, operators. So that automatically brings the spotlight on fuel economy. And if you see the fuel economy imperatives, each geography is having its own set of compliances. I would be sticking to my own geography, Indian geography. In 2017, our target for fuel economy in terms of grams per carbon dioxide per kilometer is 130. But going forward by 2022, now we have tightened as a nation on this target, and we are bound to, rather, we are set to achieve 113 grams carbon dioxide per kilometer. So, and on the emission regulation front, this BS means Bharat Stage 6, which is almost equivalent or akin to Euro 6. What kind of impacts that we are talking about? By the way, we just graduated from Euro 4 kind of emission regulations to Euro 6 kind of emission regulations in Bharat Stage 6. In the month of 1st of April 2020, our fuel quality and our emission regulations on pan-India basis, they are now conforming to this Bharat Stage 6 norms. So what does it translate in terms of key emission ingredients? For example, the toughest one which are concerned with climate and ambient air quality are oxides of nitrogen, the NOx, and the particulate matter. How these two ingredients and their compliance is varying when from BS4 to BS6, when you move from BS4 to BS6. For example, in two-wheelers, the oxides of nitrogen are reduced by 75% compared to BS4 levels. And particulate matter, for the first time for two-wheelers, the particulate matter regulations are introduced. Three-wheelers, there was no limit so far, but now some limits have been introduced for NOx, and particulate matter was reduced by 50%. Passenger car vehicles, for gasoline vehicles, 25% NOx has been reduced. For diesel passenger cars, 70% NOx has been reduced. Similarly, particulate matter, it is reduced by 80%, and particulate number, this is a very significant development. Particulate number limits for the first time were introduced for passenger car segment. But the most stringent tightening as far as NOx control is concerned, it happened in commercial vehicle segment, where the NOx was reduced by a whopping 90%. And as far as particulate matter is concerned, new test cycles were introduced, limits were reduced by 50%. Again, here also particulate number was introduced. So what is beyond BS6? This we already have achieved. Our automobile industry in India and our fuel industry, the petroleum industry to which I belong, we all are complying. We have complied with this, and we raced against the time to raise the fuel quality, to alter our refinery architecture to produce these kind of fuels. Similarly, the automobile industry has pumped in so much of money, both industries put together. Now, any new vehicle that is coming on roads post 1st April 2020, they all meet Bharat Stage 6 emission norms. So what is beyond? Globally, people are talking about onboard diagnostics, further tightening of NOx and particulate matter in the post beyond 6 into 2021, 2022 and 23. And it would be further tightening where second stage onboard diagnostics can be introduced beyond 2024. In terms of fuel economy legislations, there will be 8 to 13% fuel economy improvement would be there than what it exists today, which was introduced. The fuel economy CAFE like fuel economy norms were introduced in India in 2017. From whatever we are having today, there will be an improvement by 13%. And as I mentioned in the previous slide, the carbon dioxide emissions will be reduced from 130 to 113 grams carbon dioxide per kilometer. So, lot of technological changes when you talk about the vehicular segment, whether it is two-wheelers, three-wheelers, passenger cars, heavy duty diesel segment, transmissions, you name anything, there is a lot of technological interventions. A lot of after treatment devices have come in, whether it is diesel particulate filter, diesel oxidation catalyst, selective catalytic reduction. This is one very prominent after treatment device, especially for commercial heavy duty segment. Lean NOx traps. These are for passenger cars to meet the BS6 compliance. New injection systems, direct injection, turbocharged, downsizing, automation has been improved, hybrids, electric vehicles. I mean, you yourself have shown in your introductory slide, there can be several degrees of hybridization happening in mobility segment. So these are all going to pose a lot of challenges for the lubricant to cope with them, to be compatible with them, and to meet the performance standards laid down by these technological challenges. So let's talk about what is the generic change in lubricant chemistry. Whatever may be the chemistry, but whatever may be the type of lubricant, the chemistry has undergone change. Whatever chemistries that we have been using, uh, now after treatment devices, the compatibility of a lubricant with after treatment device is the sole theme of lubricant reformulation when we are graduating to BS6 regime. And with that came the new concept of low SAPS engine lubricants. SAPS means SA stands for sulfated ash, phosphorus, and sulfur. So this diagram gives the deleterious effects that each one of them, sulfated ash, what kind of impairment that it can cause to various after treatment devices, what kind of deleterious effect, negative effect that phosphorus, excessive phosphorus can give, and sulfur. So is the case. So all these parameters have been regulated, and new chemistries have been inducted into the lubricant additive arena, so that these after treatment devices can function properly, optimally, and to their 100% efficiency, so that emission reduction is sustainable and emission reduction is durable throughout the life of the vehicle. Um, Now coming to fuel economy via mobility lubricants, this is the main focus of my talk. Um, for all the clamor that fuel economy that we are talking about, how much fuel economy that we can really attempt? If you see the energy cycle or the combustion cycle of an internal combustion engine, the fuel which is combusted, it generates energy, but it is lost in exhaust and air, majority of it. And mechanical losses account for 16%. Um, drivetrain accounts for 10%, and finally the energy that propels the wheels is 12%. So with a right kind of lubricant, we can aim at minimizing this mechanical losses of 16%, and that too frictional losses are around 5 to 8%. So our sole focus is on how we can minimize this friction and how we can add up to the overall fuel economy equation of the vehicle by whichever means, whether it is engineering intervention or lubricant intervention. But when we talk about these interventions, lubricant intervention is a much cheaper option to garner a significant amount of fuel economy for the vehicle compared to the engineering interventions. This graph clearly depicts percentage fuel consumption reduction per investment of US dollar. So you see the engine friction reduction, cam phasing, cylinder deactivation, gasoline direct injection. These are some known concepts, known engineering interventions to get the fuel economy. They all are extremely costly, and the overall benefit that they offer are much, much less. But with much cheaper cost, the low friction lubricants can offer you a substantial fuel economy. So it's all the more imperative for all of us lubrication engineers and chemists and formulators to focus on how we can optimize the lubricant for fuel economy. So here comes the role of tribology in optimizing a lubricant for improving efficiency. The famous Tribeck curve, the three lubrication regimes, the boundary lubrication, the mixed lubrication or EHD lubrication, and the hydrodynamic lubrication. In each of these regimes, lubricant can play a role. Customized lubricants, base oils and additives of the lubricant, and screening methodology for each of these regimes. There can be a separate screening methodology which will act as an optimization tool for achieving that kind of fuel economy in each of these regimes. I would be illustrating with some examples of each of these regimes how tribology plays a very key role in optimizing the fuel economy credentials of a given lubricant. But lubricant is also having its own limitations. If you compare the maximum fuel economy impact, the driveline lubricants and the engine lubricants put together, they can offer you in all 4% of fuel economy. This is some comments pronouncement way back in 2007. So let's talk about hydrodynamic regime. Going further, this is a famous diagram which illustrates the virtues of concept of multigrading in lubricants. The green line is the multigrade lubricant, and the blue line is the monograde lubricant. So the whole story is how you can maintain optimal viscosity across the temperature regime of operating temperature regime of a lubricant or an engine. For in extremely high temperatures, maintaining because they will thin down, so maintaining some optimal higher viscosity, and at extremely low temperatures like -20, -40, -20, -30, the monogrades tend to solidify or freeze at that point of time, maintaining some even some low viscosity. That is the name of the game, and multigrading offers that. Viscosity index improvers, various kinds of polymeric substances, they actually enable the lubricant to achieve this kind of diverging and conflicting behavior, non-Newtonian characteristic to the fluid. Thinner the fluid, it gives less friction and more efficiency. Thicker the fluid, it gives more protection and durability, but the fuel economy would be casualty. So the whole game would be how optimally you can balance these two conflicting situations. You need thicker fluids for durability, and you need thinner fluids for fuel efficiency. So how do we manage this challenge? Then getting some deep dive into the tribology, the hydrodynamic friction and the hydrodynamic lubricants for hydrodynamic friction can be very well optimized by tribological instruments like mini traction machines, by following the traction coefficient. It is ball on disc, where you can simulate many sliding conditions that exist in many parts of the engine or transmission for that matter. Here one graph really depicts the utility of this traction coefficient by mini traction machine. You see, this is our own lab data. We have screened group 1 base oils, group 2 base oils, group 3 and PA4. If you are able to see the correct colors as I'm seeing on my screen, you see what a clear distinction that this mini traction machine can achieve. Clearly the group 3 and PA4 are distinctly discriminated compared to group 1 and group 2. Group 1 and Group 2 are mineral, and they are with dissimilar composition. They are having bigger molecules, smaller molecules, disorderly, relatively disorderliness is more. That's the reason why the traction coefficient is higher in Group 1 and Group 2 base oils. Compared to that, Group 3 is much more organized, and PF4 is the ultimate universal synthetic base stock, where the monomers, the size of it, the everything can be designed, pre-designed, and so the frictional forces can be kept minimal. That's how the traction coefficient was much lower, distinctively lower for these two base stocks. So these kind of screenings are extremely important for us to select the right kind of base stock for a given application and for a given type of lubricant formulation. So these kind of tribology screenings will come very handy for lubricant formulators, those who are developing. One more time-tested parameter is high temperature, high shear viscosity in predicting and optimizing the fuel economy credentials of a given lubricant, whether it is a passenger car lubricant or a heavy-duty diesel engine lubricant. You see, this is a graph. This is a very popular graph from Lubrizol, thanks to Lubrizol. They have plotted the fuel economy versus high temperature, high shear viscosity. When I say high temperature, high shear, the temperature is 150 degrees centigrade. This is a ASTM standard test, and the shear rates are 10 raised power minus 6 second or second inverse. As you go down the viscosity grades, from higher viscosity grades to lower viscosity grades, and as the high temperature, high shear viscosity also goes down, then the fuel economy will go up from 1% to 4%. This has been validated by the M111 FE European fuel economy test. This is also very popular Mercedes-Benz engine test, and that establishes clearly the relation between high temperature, high shear viscosity and the fuel economy. And if you want to talk in terms of composition, the temporary viscosity loss, or if I have to put it more scientifically accurately, the viscoelasticity of the polymer that you are incorporating into a multigrade lubricant is what it matters for achieving the fuel economy. The higher is the viscoelasticity of the polymer, and again, viscoelasticity can be controlled by many structural features of the polymer that you are selecting, and that viscoelasticity controls the high temperature, high shear viscosity, which in turn is having a telling impact on fuel economy. And it has become mandatory now to have the stipulated high temperature, high shear viscosity in passenger car lubricants as well as heavy duty lubricants in American Petroleum Institute's specifications, also ACR specifications, the European counterparts. In fact, when we talk about low viscosity and higher fuel efficiency, Japanese are the front runners. We must give credit to Japanese that they are the people who actually push the famous SAE J300 viscosity classification to introduce lower viscosity grades, which were unthinkable just a decade back. These are interventions only of 5 to 6 years old. These new grades like SAE 12 and SAE 8, these are the new low viscosity grades which can offer the maximum fuel efficiency to passenger car lubricants. And slowly, not to that extent, these are popular in heavy duty diesel segment, but they are also now the heavy duty diesel segment is also now slowly getting acclimatized and accustomed to reducing the viscosity of their engine lubricants. Coming to now, so this is all about hydrodynamic regime, but when you come to the boundary regime, how the fuel economy can be achieved or derived in a boundary regime when a lubricant moves to a boundary regime. So boundary regimes are characterized by high power densities, high temperature operations, and stop and go operations, and very light viscometrics. The lighter viscometrics, because the film thickness becomes very, very small, very, very thin, so there might be increased boundary lubrication. So here is again a Strybeck curve. We keep getting this curve. When we are talking about lubrication, we can't do away with this. It is almost become indispensable. So in boundary lubrication regime, the friction coefficient, additive selection and additive chemistry are becoming very, very important. But as you move to hydrodynamic regime, as we talked in the previous section, the viscosity plays a greater role. But majority of the vehicles, majority of the lubricants operate in the intermediary section of mixed lubrication regime. So here your viscosity as well as your additive chemistry becomes equally important. So I just want to introduce another tribological screening tool in SRV machine, especially SRV. SRV is an oscillating test, roller and flat disc, and you can really incorporate any kind of material simulating the actual engine metallurgy, and you can operate through various speeds and loads, and you can measure the friction coefficient. And here is again a very, very illustrative example of how a friction modifier as an additive can bring about a very, very distinctive difference in terms of friction coefficient, thereby improving the fuel economy. See a host of oils that we tested in a particular set of conditions in SRV. The one which is inhibited with a right kind of friction modifier with right chemistry as well as right concentration or dosage of the friction modifier, see how distinctly the friction coefficient is lesser compared to the rest. This is the kind of distinction that formulators are looking for, and that's how the friction modifiers are selected, and that's how they are getting incorporated into various various formulations. And these friction modifiers can be organic friction modifiers, inorganic friction modifiers, whole lot of metallic species are being pressed into service as friction modifiers. The most popular one being moly-based friction modifiers. So that's the boundary regime. Then some more direct examples of passenger car motor oils and heavy duty diesel engine oils, which were made fuel efficient. How did we make them fuel efficient? What kind of screening that we have done in formulating them and launching them in the market? I'll first talk about passenger car motor oil fuel economy. We have again taken resort to MTM traction coefficient studies. Also, we have a friction torque test which is conducted on a actual engine. It can clearly distinguish the viscometrics, the effect of viscometrics as is depicted in this graph, and also at over a wide range of temperature range. And it can also distinguishes relative efficacy of the friction modifier chemistries. And both these tribological screenings can be validated by the actual fuel economy measurement in a vehicle on a chassis dynamometer. We invariably use in India modified Indian driving cycle. We don't because that is more akin to our driving conditions than world harmonized testing cycles or any other cycles. So the good oils out of the screening of this friction torque test as well as the MTM screening of traction coefficients They are all validated by this chassis dynamometer testing, wherein the lower, as you go down the viscosity, viscometric scale, the fuel economy has been actually improved, and you can get as high as 6.41 in the set of conditions that we have tested in a gasoline engine, in a four cylinder gasoline passenger car. Coming to the heavy duty diesel engine, till very recently, I think till 2010 or maybe till 2010, fuel economy via diesel engine lubricants is not a very accepted concept. Only fuel economy means only passenger car engine lubricants can give fuel economy. Diesel engines are otherwise very fuel efficient, and a lubricant cannot make much of a difference on account of fuel efficiency in diesel engine. This used to be the concept, but we have proved wrong. Many people in the world and many lubricant formulators have proved that wrong. And also there was an anathema in heavy duty diesel segment to go down the viscosity line from 15W40. SA 15W40 was gospel viscometrics, and going below would be almost people used to perceive it would be detrimental for the durability of the engine. So we attempted going for the first time at least in our country, to 10W30s. Today, of course, 10W30 is a very popular grade in heavy duty diesel engine lubricants also. But when we did it in 2010, we have to face a lot of resistance from engine manufacturers and the users as well. So the sole apprehension was that when you reduce the viscosity from 15W40 to 10W30, the durability would be at stake. So we took on the gauntlet and took the challenge of maintaining the durability at the same time, garnering some substantial fuel economy by reducing from 15W40 to 10W30. Various kinds of additive chemistries were screened. Again, SRV in line contact, SRV experiments in line contact came very, very handy for us to give that initial screening and initial insights of how the fuel economy would be by reduction of fuel efficiency. And we could able to validate this not only in chassis dynamometer, but also we could able to validate these figures in the actual field trials. So that's how the concept of a green combination, fuel economy combination, combination of engine oil, transmission oil, and axle oil has come into the fore. And our company in India is one of the first one to introduce this green combo of three lubricants, three fuel efficient lubricants. And our claim was that if you change the set of three lubricants in a truck, heavy duty diesel engine truck, you can garner a fuel efficiency as high as 4%. And we have proven it, and we have validated in the actual field. So what all we did is, we have only done to reduce the viscometrics in engine oil case from 15W40 to 10W30. In axle oil, the traditional viscometrics is 85W140. From there, we have reduced it to 80W110. And in transmission oil, the conventional 80W90 was replaced by a lower viscometrics 75W80. While doing so, we were very, very conscious for all that few percentage points of fuel economy that we might get extra. We were extremely, extremely conscious about durability, and we have augmented the anti-wear chemistry of the lubricant formulations of all these categories of lubricants. And when it was validated in the field, we could actually get the real benefits without compromising anything on durability aspect. Here I must mention that for heavy duty diesel segment, we have devised our own duty cycle. We call it as Delhi bus driving cycle. This is not a standard cycle, but in Delhi, they say famously, in peak hour traffic, the average speed of a heavy duty truck or a vehicle is 5 meters per second. 5 meters per hour, sorry, not second, per hour. So that is the kind of speeds, that is the kind of stop and go conditions that National Capital Region Delhi experiences. So we devised a duty cycle around the Delhi driving conditions, and we adapted in our chassis dynamometer, and we could able to get these kind of numbers. And when
Dr.
we did
Ramakumar,
yeah.
I'm sorry, you have 3 more minutes if you can come to
Yeah,
the.
yeah, I'm about to finish.
Thank you.
in
Thank
couple of-
you. Yeah. Yeah.
So what kind of monetary advantage? These numbers look very small when you talk about fuel economy, but on an annual fuel saving benefits, they run into millions of rupees. Even the drain periods can be introduced, extended, and there also you can do that. So tractor lubrication is another segment. In fact, India is the largest producer of tractors. And in tractor lubricants, besides engine and axle, there is a wet brake lubricant, which is a key lubricant, which is employed in many oil immersed brake system containing tractors. And chatter is a big problem, perennial problem in these tractors. And a lot of theories are there. There are static friction, dynamic friction. You optimize one, the other will go off, and there appears a chatter. And chatter is a big irritant for the user. So they hold lubricant solely responsible for the chatter, any user. So the best and optimal condition is you should have low static friction. At the same time, at the right kind of time, you should have high dynamic friction so that the chatter would not be there. And we could able to screen properly in a John Deere screening test at SWRI, and we could able to get a absolutely noiseless lubricant, which is in. I would only take one more example. This is an example close to my heart. See, marine lubricant formulation is a different ball game. Unlike the case of passenger car motors and heavy duty diesel segment, where there are standard engine tests, where you can optimize the lubricant formulation before it is put in the actual engine, or put it in the field. But for a marine lubricant, there is no standard engine test. There is no universal specification, unlike the case of PCMOs and HDDOs. So you have to totally rely on your gut feeling, or you have to rely on tribology. So we relied on tribology, and we have a high frequency friction machine, which actually is a reciprocating machine, where film thickness is measured when contact potential is observed, and you see a good oil and a bad oil. The lubricant film between piston and cylinder liner, especially in marine two-stroke engines, huge marine two-stroke engines, cylinder liner wear is the key property, key performance attribute, which is expected out of marine lubricant. And to optimize that, there is no other engine test, there is no other means. So we have devised this tribological screening, and see this in a bad oil, you see these valleys in this graph, which clearly indicates that the film is forming between piston and liner wear, but it is getting broken. And such an uneven film will lead to catastrophic cylinder liner wear. On the contrary, see the good oil, where initially there might be some furrows, but fairly the film is constant, which clearly indicates that because this is a hydrodynamic regime, and definitely the film thickness matters, film thickness of the lubricant matters, and also it's a once through system. So lubricant is injected in microliters, and film has to form, and it gets evaporated, and a fresh film has to be replaced. So in such a complex scenario, maintaining a uniform film is very important. We could able to very accurately predict by this tribo screening. Believe me, based on this, I have run 2 marine shipboard trials, paying huge money in terms of insurance premium. Ultimately, we could get the approvals of the original equipment manufacturers. That is the beauty of this Tribo screening. So I'll skip the motorcycles, and I would only, this is my penultimate slide. So much of talk about e-mobility and e-cars, and transmission oils, ordinary transmission oils need to be reformulated, and noise performance is to be taken into consideration for the transmission oils which goes into these electric cars. And it's a big challenge. Like you see the film thickness of this blue line, this is the oil A, and the film thickness is lower, so viscous drag is lower, and so the traction coefficient is also lower. But I thought, I'm rejoiced, okay, the traction coefficient is less, so this should be very good. But see the noise readings, this is one of the worst oils as far as noise is concerned. So there should be a trade-off between the noise performance and efficiency and film thickness. So I think so it's a great challenge, and tribology again can come handy in negotiating those tough challenges. So to conclude, tribology plays a key role in developing customized lubricants. Friction reduction is the key for improving efficiency. Low viscosity oils need to be balanced for better wear protection and durability besides fuel efficiency. Tractor, marine, and motorcycle lubricants need to be optimized using sound tribology fundamentals. Transmission oils for electric cars also require noise-related tribology screening. I think with this, I conclude my talk, and thanks for your patient hearing. I'll wait for the Q&A session to take few questions after my second speaker would complete his presentation. Thank you very much.
Thank you, Dr. Ramakumar. Fascinating description of various elements involved in transportation. And it was very nice, the last slide, before this, where you described, the noise and vibration effect and the challenges in it. That becomes, basically you set up a preface. It's a preface for Sergio to take it up from here, I guess. The noise, vibration, and harshness have become the driving factors for bearings in electric vehicles. So the platform is yours, Sergio. So please go ahead. Yeah.
Okay, so can you see all the screen?
It's perfect, Sergio. If you can make it full screen, then
It's just now.
Yes, perfect. Go ahead.
Come in. Okay. So first of all, thanks Deepak for inviting me to this speech, to these tribology discussions, and also thanks to the attendance today, and also thanks to Dr. Ramakumar for his, as you say, fascinating speech. I'm not going to be that scientific as Mr. Dr. Ramakumar. So I will be more. My goal is just to bring to the table some questions and insights addressing the challenge of the electrical vehicle and basically the challenge when it comes to bearings. It is my main business in the last 10 plus years. Not only bearings, also I have some experience in other automotive components related to engine cooling or engine heating, and also some other experience in other fields like telecommunications. But it's true that bearings probably are the most, also by using the same adjective, the most fascinating elements I ever tried before. So let's go on my speech. Basically, I want to tackle 4 main chapters or topics. First one is how the society shape the tomorrow components or tomorrow bearings. Some of my insights were also discussed before by Dr. Deepak and Dr. Ramakumar. What that means electrification. I will try to provide some pictures of the different electrical vehicles or electrical models, either hybrid or battery or and so on. Third is when we see versus we see the future versus electrification. It seems that the future is really black. So, but I think there's a new hope for bearings. I will dive in this topic and provide some insights that bearing makers, not only us but also other bearing makers, are looking as a kind of challenge for us. And finally, what is the response of the company that are representing today to these new challenges? This is a summary of how the society, society drivers shape tomorrow, not only bearings, but also components, mechanical components, but let's talk about bearings. So some of them are already mentioned before. So we have some as society, we have some trends, social trends you see on the here on the top left corner. Those trends move to address some kind of technological drivers. There's here. If we move to the electrical mobility that you mentioned, Deepak, the mobility as a very, very nice definition with like flexibility and sustainability. So we have some challenges on the electrical mobility, and those challenges also going down when it comes to bearings also provide or put in front of us some other challenges. I will try to explain. So going in some details, we have, this is a partial view of the predominant social trends. Of course, there are some others that you mentioned before, but in general, we are all concerned about the environment. We are living in a sharing society by sharing cars or by sharing other services. We are for sure in the digitization era, and this is all of this is in a global basis. So that could be some of the top 5 of social trends. But basically, those trends, social trends, provide or lead to some technology drivers. I summarize, according to my opinion, which are the main technology drivers for all the components, not only for automotive, but for any kind of industrial field. So we are talking about more efficient products. That's also Mr. Ramakumar addressed before. We are talking, of course, about electrical mobility. We are talking about new functionalities for the components, for systems, for the services that we have to provide to the society, and we are also talking about IoT, so Internet of Things or mechatronics in general. So we are more and more pure mechanical components that were at least pure in the past. Now they are also including some electrical or electronic features. So we have living in a hybrid model, a mixed model of mechanics and electrics. Moving to the going down one step forward into the electrical mobility, we are also facing with really some big challenges because the next generation vehicle is going to put in on us and the different manufacturers, different players, not only manufacturers, is putting new challenges in the powertrain. Is the one that is more is closer to me, and on the chassis, on the exterior or in the interior of the vehicles, and you can see that the impact on the powertrain, or the expected impact on the powertrain due to the electrical mobility, is the highest versus the other 3 sectors. So at the end, the powertrain, so the components that are involved in the powertrain and eventually the bearings are going to be impacted somehow for this trend, or this movement to electrical mobility. That is for sure something that is going to be there for the next years. And finally, some of the challenges that we see as a bearing manufacturers, we see when it comes to bearings. Also, Dr. Ramakumar pointed out some drivers in terms of efficiency for lubricants, efficiency, noise, vibration, friction, behavior, durability. If we talk about bearings, those are the main drivers we need to, the main challenge we need to address in the next years. we need to talk about insulation, covering insulation. We have to talk about the cooling, because the heat created by the batteries. We are going to talk about noise, torque, efficiency, of course, speed, and also integrability into a new architecture of vehicles. Before going in detail on the response or potential answers to those challenges, let's talk about electrification. Let's put that some figures on the topic. There are a lot of analysis. You also put one, Deepak, in your presentation concerning the expected evolution of the battery electrical vehicles in the future. I just take this graph from a white paper, and you can see that from different sources: US, Bosch, Schaeffler, Faurecia, Continental. What is the expectation in terms of the trends, of the expected trends in terms of electrical vehicles penetration? So all in all, let's say that for an average for 2025, we are expecting like 10% of penetration, and for 2040, we might expect between 25-30. Just take these as rough numbers, but that could be used as a kind of a baseline for next discussions. Apart from this penetration, we are going to see different penetration depending on the regions, and depending also on the kind of transport. My main topic is or our main business relates to heavy vehicles, heavy duty vehicles. So basically trucks, trailers, and buses. So that's why I put this in my presentation. And you can see there that there is a variable speed on the penetration, and a different also market share depending on the regions, and depending on the distance that the trucks have to cover. We see the very different approaches depending on the regions, like with China moving on the bus very fast, with US being more reluctant to get heavy trucks based on electrical power. Europe probably more due to the regulation that was also explained by Dr. Ramakumar, more prone or more eager to implement this technology. But in general, we see different speeds, and depending on the regions, depending on the geographical area. Also, if we talk about architecture, some of them were mentioned before, but what does it mean electrical vehicle? It's not just one type of vehicles. At the end, we'll have like 3 or 4 different vehicles architecture living together, sharing the roads. We have, of course, conventional the conventional hybrids that are basically a combination of diesel or gasoline power or internal combustion engines plus some electrical motors and batteries that can provide an extra power to the internal combustion engine, but they cannot be plugged in, so they cannot be plugged in the network. Then we have the plug-in hybrids that are electrical vehicles that can be with a smaller battery that can be plugged into the network, and then also having a conventional gasoline or diesel engine. And we have also the pure electrical vehicles, so they are called battery electrical vehicles that are using store energy in the battery to drive the motor, to drive the electrical motor. In this case, we have issues related to the voltage that will have some effects and consequences also on the mechanical components, as we will see later on. And then we have finally hydrogen fuel cell electric vehicles, where the battery is the battery, as we understand, the batteries is replaced by a kind of fuel cell that generates the electricity from hydrogen. So we are those 4 architectures at the same time, and we might have those architecture at the same time on the roads. So on all of them have probably different requirements in terms of components or in terms of bearings. Then what that brings to the table in terms of what about the bearings? Because we are talking about the different speeds and market penetration. We're talking about different architectures. When it comes to the components, when it comes to bearings, what is going to happen? Well, it's clearly it's a reduction. What we see is a reduction of bearings in general in the vehicles, in the cars, or in the trucks. Now we have wheel bearings, we have gearbox bearings, we have bearings in the differential, we have bearings in the axle. In the electrical engine, on the electrical vehicle, we have basically wheel bearings, maybe some axle bearings, very simplified gearbox. So if we put those trends or those expectations in numbers, in figures, we have that for an internal combustion engine, we might have between 80 and 100 bearings. That's a rough number. In a battery electrical vehicle, we have between, let's say, 30 and 40. Yeah, so 25 to 40, just to simplify. So we'll have between 50 and 75% less bearings in an electrical vehicle than compared with an internal combustion engine. So then, what to do? What is the room that these situations saves for the bearing makers? But still, I think there are a new hope also for the bearing makers and for the bearing industry. Fortunately, at least in the automotive sector. And this is based on some insights that I am just putting all together and collecting from also other colleagues from the industry, but that provide us at least some futures for the bearing. So we need to still to develop and to invest a lot in research and development to provide to feed the market with solutions coming from the challenges provided by the electrical vehicles. Some of those challenges are we have to deal with a less space, probably with less space. So we have to minimize the requirements in space, but the power still will be the same or even higher. So we need to go for sure for more compact power train designs, trying to reach some weight reduction, and also working on decreasing the operating temperatures, and at the end enhancing the overall power train efficiency of the bearings. Dr. Ramakumar put in his presentation a note about the savings for a 250 fleet. 250 trucks fleet of around 200,000 euros with just 1% of fuel efficiency. So bearings can also take a role in this challenge, and then we are talking about kind of fuel efficient bearings or fuel efficient solutions. So another insight on the electrical vehicles that we have motors there. We have electrical motors running at very high speeds. Like such a 30,000 RPMs. What at the end is leading to a huge strain on the bearings. So we have to consider that the new designs of bearings must withstand these high speeds and the acceleration and the temperatures generated by those motors. So at the end, we are talking about some kind of hybrid bearings as a kind of solutions for this challenge. What else? We have also electrical motors. We have current flowing, not only instead of diesel or gasoline or besides diesel and gasoline, we have current. We have electrons running on the system, flowing on the system. So we have to take into account the effect of this high frequency voltage running on the system, working on the inverter. and this current also could lead to some leakage that can imply some pitting on the surface of the current steel bearings. So then we need some solutions to avoid such kind of failures. Then we are talking about insulated bearings or hybrid bearings. Also, the topic of noise. This is considered in different ways. So the electrical vehicles, they will not able to mask the bearing noise. So up to now, we have some bearing noise. We have, this could be a sign of failure of early failure or a potential failure in the future. But in some cases, there is nothing related to failure, but it's something that is not either well assembled or well lubricated, and then we feel a noise. So in the electrical vehicle, that there is mostly no noise. We'll need bearings that will run more quietly and more softly, and so then we'll need also some either coatings or hybrid bearings to cope with this challenge. What else? Also, we need surface coatings. So the tribology is basically here. We need to enhance the properties of the surface, or the tribology properties of the bearings, and then we need to count on new surface coatings, on also new oil and grease lubrications to deal with this topic of performance enhancement. Other insight is also we are expecting that the bearings and the components in general of the vehicle, but the bearings in particular, will have to work harder by time being. So because the vehicles will become more sophisticated and with more electronics and with more services, with more functions. So that also will have an impact on the bearings. So we need to provide or to work on more robust bearings. So that means that we need to provide to the market, to the customers, like the end users, like kind of extended life bearings, or even e-bearings. We take into account that there will be some connection to the rest of the components of the vehicle, or we need also to track the conditioning monitoring of the bearings during the running to keep the vehicles staying on the road rather than inside a repair shop. And last but not least, also we have to consider the effect of the electrical vehicles on the lubricant, because lubricants and bearings are a couple that cannot be dissociate each other. So at the end we have batteries instead of an internal combustion engine, and the batteries at the end is a generator of heat. So we have to deal with this heat increase, and we have to manage how to cool, how to improve this transfer capability, and to keep the whole system under a good temperature condition. And with all these insights, so most of the bearing makers, and in particular Fersa, the company that I'm representing today, is working on some of those solutions. We have what we call our product roadmap for electrification. So we have identified certain set of products to deal with the challenge that I mentioned before, or some of the challenges I mentioned before. We are working on some kind of electrical insulated bearings to deal with the current leakage and with the current running around the system, with some kind of features, as I will not explain in detail. We have also the ceramic bearings, that is a sound combination of steel material on the rings plus some ceramic material and silicone nitride basically on the roller elements, either bolts or rollers. Also that can provide a very nice features in terms of very nice performance in terms of noise, in terms of weight, of course, in terms of electrical insulation. We have also some kind of coated bearings based on some kind of DLC coatings, also to deal with friction topics, and to deal with high speed topics, and also durability topics. And we are also what we call our connected bearings, or our e-bearings, that this is called MOS, is modular sensor system bearings, that this is intended to measure some of the variables around the bearings and provide those measurements by Bluetooth communication protocol to the central unit or to a mobile of the user, and then inform or report about the situation, the status of the whole system. So at the end, you see that we have some really strong challenge, high challenge in front of us in terms of society, in terms of electrical mobility. Those challenges are those trends or those situations are going to put under pressure in general the components of the powertrain, and in particular of the bearings, and for sure the number of bearings in the vehicles in the future will be lower than as per today, than currently, but there is still some challenge, some technical challenge that we need to address also, and so there is room for improvement. There is room for the bearing makers to still working on the bearings, to research about new ways to deal with the challenge that the electrical vehicles is putting in front of us. That's all. Thanks. You have my data there. I'm free to
Thank you very much
to answer any kind of question.
Thank you very much, Sergio. Fascinating description of various elements involved in electric vehicles and bearings. I think there are more challenges in this area that needs to be addressed, as you guys know. We will have some questions to help us to understand those challenges, I guess. So guys, whoever watching it, go on the YouTube, you have those questions, you have the top chat section on your top right. You can ask questions to Sergio and Dr. Ramakumar, and both of them would be there to take your questions. And we have the first question to Dr. Ramakumar from Vivek Jain from BPCL. So his question is, what will be the expected fuel economy reduction when the high temperature, high shear is conducted at 100 degrees Celsius?
But the standard test condition is 150 degrees centigrade, that high temperature, high shear viscosity, because most of the limits that API stipulates, you must be quite aware that it is at 150. When you reduce it to 100, I guess the fuel economy benefit will go down.
Right.
My experience is that it goes down.
Okay.
Proportionally.
I have few questions. Meanwhile, an important question that's basically not bothers me, but kind of puts me into the challenging position, being a tribologist. What do you guys think about it, Sergio? That the impact on tribology would be, say, what you see in the screen is 3 elements of transportation, right? One is the airplane, and you see the cruise speed of 850 kilometers per hour. And if you look at the energy consumption, it is 515 watt-hour per passenger per kilometer. Then you have the high-speed trains. There you have 250 cruise speed, 116 watt-hour. Then comes the Hyperloop, which has 1,000 kilometers per hour cruise speed, and if you look at the energy consumption, it's 40 watt-hour per passenger.
Yeah.
And the beauty is there is no data on the carbon emission. That Hyperloop is could be completely fueled by renewable energy, and it has very few moving parts, right? Where would the lubrication fit in? Where would the bearings fit in? What is your thought on this? If we switch to Hyperloop, where would the tribology be?
Good question, Dr. Sergio.
Yeah, difficult to say. It's like I can say that when we start to think about the electrical vehicles, like 5 years ago, we start to to hear about this technology coming, the expectations were, I mean, no one knew about the expectation when it comes to, I would say, bearings, and I would kind of extend to tribology. So to be honest, I cannot, I have no vision about what the hyperloop and other technologies could affect the tribology of the
Right, right.
Today, I mean, 10 years ago, happens that it seems that no bearings will be required, will be necessary in the electrical vehicles, and we see it 5 years later that still they are, as an example, bearings that are basically just running element or rolling elements. Bearings are still there. So what happened with what will happen with the hyperloop? I have no answer right now.
Okay.
No idea. I must confess, no idea.
True. Dr. Ramakumar, where do you think, if we switch, where is lubrication other than aerodynamics? Yeah.
It's some kind of crystal ball gazing that I need to. If I talk from lubricant viewpoint,
Right.
conventional wisdom says that higher speed regimes are generally hydrodynamic.
Right.
And you're talking about cruising speeds of 1,000 odd and all. But
Right.
is it really true? You have really had given a thought-provoking question to me and my team who is listening here. And
Right.
it's simply hydrodynamic or something more need to be looked into. If it is purely a hydrodynamic game, then we are now quite adept
Right.
at dealing with this kind of.
Right. Right. Because it also has the takeoff, it has initial run-in period as well before it reaches the cruise speed, where it's more or less flotation there, and there are power trains, and could be interesting to look at. That's an interesting field, because in European Union there has been the recent development is funding these hyperloops. Especially, I think, Sergio, you might be aware of it, especially as an alternative for the airplanes. There's a funding flowing to Hyperloop.
Yeah, with the Green Deal in Europe, there are probably more investment, more money coming to this kind of initiatives.
Right.
Let's meet in 5 years. Let's see. Maybe we have an answer for your question now.
Sure. Thank you. We have a question from a PhD student from University of Ghent, and the question is how to screen or test the oils at high rotation of bearings. Is there any standard test method? Sergio, you want to take the question first?
Say it again.
Is there any test method for testing the oils in high rotation of bearings? I think he means to say high speed bearings. Is testing oils there? Is there
high speed is this is more than 10,000 or 30,000.
Yeah. Is there a test method for it, Sergio?
I don't know that there is. I don't know that we are usually using our typical speeds for testing our 1500, 2000, 3000 RPMs. More than that, I never experienced. We never realized. So.
Okay, Dr. Ramakumar, do you have any experience in testing oils at high speed? 20,000 RPM, 30,000?
We used to read, especially some of the multinational counterparts like Shell and Total. They used to talk about bearing oil film thickness, which can be measured by some tribometers. BOFT is a good concept to predict the performance of a lubricant in high-speed bearings. Mostly gasoline engine or the passenger car segment. It used to be there, but precisely Can we really measure or not? My knowledge is more towards lubricant testing. So in such high-speed rotational bearings, what kind of film thickness that lubricant maintains and how it is going to impact the performance of the bearing. I think that kind of screening can be done with, it's already there. Some test methods are there. They're not standard definitely, but they are there. Some papers are there, published papers are there on that
Okay.
aspect. If that student is asking about that.
Right. Right. Nice. Um, this takes me to another interesting question just from my side. Um, we talked about flexibility, which is a driver for mobility, gives us the freedom. And what I have understood is that the ride sharing, the car sharing, or carpooling has an effect on lubricants business as well as could be in the bearings industry as well. So just the idea here, um, the lubricants would be sold to the fleet owners. When it happens, the markup brand price would not be sustainable in that case. So there is this idea. So I would like to hear from Dr. Ramakumar what he thinks about it when you have to sell lubricants to the fleet owners rather than to the individuals. Then how would that affect the business?
So first of all, post-COVID or during the COVID also, the first concept disruption is that this shared mobility is one concept which was gaining currency pre-COVID, just 3 months back, till 3 months back. This is the one which is disrupted, and people are saying that now that concept is a big no-no for every one of us, and every prediction from automobile industry to oil industry that the gasoline sales are going up. I'm saying this, and the automobile industry is saying today there's a big news item in Indian newspapers that the second-hand pre-owned car sales are rising like anything. So everybody prefers a personalized mobility, and so ride sharing as a concept, I think COVID has pushed it backwards. Having said that, if suppose till 3 months back, yes, this is the new trend every one of us were working on. I feel as a lubricant marketer, I see it as an opportunity, because selling to a individual customer the lubricant, the right kind of lubricant, the usage of right oil for right application, RORA, uh, was a distant dream when you are selling to individual consumers.
Right.
But selling to a fleet owner, you can still educate that fleet owner to use the right oil for right application. So at least the quality of lubrication can be improved, and quality commands premium.
Right.
The
Right.
businessman in me says this.
True. So Sergio, do you think this will have an effect on your business in bearing industry?
I mean, first, everything related to sarin now, it's just like we are scared about that. So no more sarin due to the pandemic in the next months probably. So that will affect the sarin business in general, sarin services. And in terms of business, I mean, one of our main customer are the fleet owners already. And for trucks, I mean, trucks are serving fleet owners, and for trucks are sharing the vehicles and between the different drivers and different regions. So we don't see any. I cannot see any special effect, because they are buying in bulk the components of the bearings, or they are buying depending on the very distributor, single distributor. So I don't see any additional impact on, because we are already working on this kind of sharing vehicles on the truck. For example, truck industries is used to work on that concept.
Right. Nice. Yeah, makes sense. Dr. Ahmed has a question to Dr. Ramakumar on How is the vegetable oil or bio oil status in India for mobility lubricants?
Yeah, I think vegetable oils per se, when you base your formulation on vegetable oils, they are more prone for oxidation stability, and so the thumb rule of the thumb is that the drain intervals have to be reduced to half whenever your lubricant is based on vegetable oil. But many studies have, many OEM studies, what to talk of oil marketing company studies, but many OEM studies disproved this myth with the right kind of antioxidant inhibition into the lubricant formulation. Vegetable oils are as good as any other oil, and the biodegradability of the lubricant will improve.
Right, right. Question to Dr. Sergio: how to avoid bearing damages due to electric arc, electric current? I think when moving towards electric vehicles, the few of all the bearings are the number of bearings are less.
Yeah.
When they connect to the e-motor, because of the fluctuating current, you get the
Yeah.
electric discharge machining
Yeah.
on your.
We see basically two solutions. One is the less costly, that is applying kind of coatings, uh, basically are oxide of alumina or aluminum oxide of aluminium. That is, they are the insulated bearings that we can provide, or we can apply this coating layer either on the outer or the inner part of the bearing. And the second approach that is more have more cost impact is the using combining materials. So having ceramic material, so almost an insulated material in the as roller element, basically is silicon nitride, and keeping the steel on for the rings, for the outer and the inner components. Those are the two main solutions to address the current leakage or the current topic.
Yeah, okay. Is Dr. Ramakumar, have you come across problems similar to this, where the bearing damages, especially the pitting and spalling related to the electric current, and I guess lubricants play a role there as well. One part is coatings, and there you have lubricants, that have to play a big, because largely the problem with the lubricants is it's a very good insulator, right? So it can create problems to the system. So what is your take on this? You have to unmute, Dr. Ramakumar. Yeah.
Sorry. And we perceive these kind of problems, but the population right now in India is too less, and we have yet to encounter any field problem. But definitely, as an imperative, yes, we agree with this kind of problem, and our formulation philosophy is to overcome this corrosion.
Okay. Um, this is a question that could be interesting for Dr. Ramakumar. Well, as you move forward 2035, you would see the volume of the lubricant would go down. However, there is a scope for increase in the margins, right? So this is a study from the McKinsey where they describe here that to get more profitability or higher margins, although the volumes of lubricants are lower, you need to do certain things. One is lubricant chemistry, and that's exactly what you have touched upon in your slides, Dr. Ramakumar. And if you see here, the emphasis is on synthetics compared to mineral. Here, do you agree with this, given the economic conditions in India, for the demand point of view?
For the synthetic lubricants?
Yes, exactly, the synthetic lubricant.
Yeah, definitely. I mean, the new generation lubricants, especially the IC engine lubricants, even marine lubricants, we have a couple of examples which hitherto are unthinkable, because synthetics pose great problems of solubility of copious amounts of detergent dosages that we inject into marine lubricants. But now there are some very, very fine-tuned detergent chemistries are there, which can hold, I mean, which a synthetic base oil can hold. So as far as India is concerned, the share of synthetic lubricants right now is approximately 8%, and it is bound to increase. It is bound to increase the share of synthetics, especially with the advent of electric cars, and most of the transmission oils and the greases need to move from mineral to synthetic. Uh, Definitely the role of synthetics is there, and that also triggers many players like us to think of manufacturing synthetic base oils within the country. Right now, every drop of synthetic base oil in India is imported.
Okay.
So that prompts us to, I mean, it's a proverbial egg first or chicken first. People say, where is the demand to set up a plant? But going forward, definitely there is a case for setting up the production facilities for synthetic base stocks. Once the production is indigenized, then definitely whatever margins that McKinsey predicted on this slide can be realized. And synthetics any day are better base stocks for any kind of lubricant, more so for transmission fluids and greases.
Ah, right, 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 right. Um, well, the last question we have before I guess Sergio had to take a leave, and then we have few questions to Ramakumar. The last part is uh, Industry 4.0, right? So digital transformation and tribology, Industry 4.0. Ducom, we are playing our role. We are automating a laboratory information system in line with, I think we had an extensive discussion with Sergio about how MOOHA could be used.
Yeah.
Sergio, what is your take on it? Especially you touched upon different elements of digitalization. Where do you see how this digital transformation help your industry, and what should be the role of a lot of tribologists in this?
Well, we are applying the industry 4.0 from some years ago, but we see basically we see the great advantages on the manufacturing point of view. So we have some less implications on the production. There are still some like the additive manufacturing. That is for sure. I think I'm a believer on this technology. I see that we have to find some room for the burn industry as well by using some additive manufacturing technologies. The rest are mostly applicable and applied on industry, so manufacturing processes and control and digital twins is what we are working more by simulating processes and I see for example what you mentioned the MOOHA software. I see that as a very good improvement of our daily laboratory routine, so the lab activities, and also to make easier for in general. I see this kind of elements. I have to pick one advantages of the industry 4.0. I would say that is the access, to simplify the access to big data and to the data that we are gathering or we are collecting in our daily activities. So I see that even for researchers or for product engineering departments or product designers, I see the easiness to access to the information is one of the major levers of the digitization.
Right, right. Thank you, Sergio. Yeah,
Pleasure.
yeah. Dr. Ramakumar, what is your take? You have multiple laboratories, multiple facilities, a lot of time series data points, a lot of images. You need more insight in one platform. So how is digital transformation going to help you to get more insight, from all these laboratories?
Yeah, I think the need for digitalization is more underscored during the recent lockdown phase. We have been talking it for quite some time now, and we have been working in a small little manner. But this pandemic and these disruptions have really prompted us to accelerate our efforts in digitizing many of the engine test benches that we have, the tribo instruments that we have, and the pilot plants that we have, so that these kind of disruptions can be very well surmounted. So we are having some firm plans, and I'm glad that Ducom is. You said that Ducom is having some ready-made solutions. So I'm sure my team, tribology team, especially Mr. Ajay Harinarayan, who is there in the audience, would be too pleased to discuss with you any of such solutions that you may offer. We are really looking for this. At least some of our key tribometers, we'd like to digitize them, make them IoT enabled, so that we can operate them remotely, we can monitor them remotely, and we can get the data wherever we are, anytime, anywhere. That's
Right.
the ultimate uh, uh, objective and aspiration.
Nice, nice. Thank you. I guess, Sergio, you want to take a leave. You will. Thank you very much for being here. I guess I will have Dr. Ramakumar for two more questions. There is one question from a Hero Group from Dr. Kaushik. Yeah.
Then I
Thank
say
you,
goodbye
Sergio,
to
for
all.
your time.
Pleasure.
Yeah. Take care.
Have a good time.
You
Bye
too.
bye.
Bye. Yeah. Dr. Ramakumar, the question from Dr. Kaushik is, what is your expertise in lubricants testing at high speed for high speed applications in railways, for example? Yeah.
Railways.
Right.
Yes, we have we have very well proven railroad lubricants. In fact, our product is the benchmark product for Indian Railways, at least. We
Right.
have years of testing, both turbo testing, engine testing facilities, and we have the experience of running mammoth field evaluation in uh, locos of Indian Railways for diesel locos. And electric, as far as electric traction is concerned, definitely we have already developed greases for some of these electric locos and synthetic lubricants. We
Right.
guess we have some expertise, definitely.
Nice, nice. So I come to the last question. This is more about people who are looking forward to looking up to you to draw some inspiration and motivation in their career being a tribologist. So you have more than 100 publications, several patents, awards. You're sitting as a board member in IOCL and few other companies, and you have done this all, I guess, having tribology at the center of it, right? So, what role did tribology play in your career, according to you? We see it from outside. We read those, accolades that you have, and you primarily your work is in tribology. You've developed, fantastic lubricants. So, what do you think has tribology, helped you to achieve where you are today?
So it's a good question. So as far as lubricant industry is concerned or lubricant application is concerned, definitely my concluding slide also says that tribology occupies the central place. I quoted one example also, and this is an anecdote that whenever I now recall that in the hindsight, such a huge shipboard trial of a newly developed marine lubricant to be monitored by the world-renowned marine original equipment manufacturers, and crores of rupees I paid as insurance premium of that particular ship where I'm testing my lubricant, and at the center of all this kind of risk-taking initiative, the one technical confidence that I have is only the tribo screening. I told you that especially in case of marine lubricants, there is no engine test, no specification that I can fall back on during the developmental stage. So all my confidence building is based on the tribo screening. And we have devised few, my thanks to my the smartness and innovativeness of my tribology team, we could able to devise certain new screening protocols which came bang on dot the prediction that cylinder liner wear is one particular parameter which can make or break the whole developmental exercise uh, in a lubricant getting accepted by the original equipment manufacturer. So it's a kind of a gamble. I mean, when I was playing that, it was a gamble, but now now I'm but it's a calculated risk, and that all that calculated part has come from tribology.
Right. Right.
So I mean, beyond lubricants also, many of the refinery, I'm talking about my own oil and gas field. Many of the refinery applications, many of the maintenance and inspection schedules and the aspects of many refinery uh, metallurgy and configurations and pipeline applications. There also the knowledge about tribology and the knowledge about corrosion science, material science, basically they all are interwoven, isn't it?
Right.
Uh, they keep one in one's good state.
Right.
So all those budding tribologists, and even now, as you rightly, as somewhere I read the other day, even now tribology is not being taught in engineering colleges as a regular curriculum.
True.
There are institutes, academia after academia, which can offer mechanical engineering, mechatronics, and things like that. So many fashionable branches of science and engineering, but very few. I think, barring IIT Chennai and ISC Bangalore in India, there is not curricular instruction, academic instruction on this very important field of tribology.
Right. You have brought up a very interesting point to end with, the how to basically it raises questions how how we should be able to bring in more tribology curriculum in, as a mainstream teaching in some of these elite institutes in India, IITs or NITs, and so I guess doing that would create more tribologists, and hopefully they will all have some more inspirations and motivations looking up to your success. Yeah.
Yeah, actually, tribology is all pervasive. You take any industry, proper tribology input and knowledge, without that, you would be wasting crores and crores of money. This was told by no less than Professor Peter Jost almost 70 years or 50 years back. But
Right.
still, but still we have not completely become cognizant of this fact to introduce this at the mainstream teaching so that the industry gets a very well trained, tribo trained workforce.
True, true, agreed. Thank you very much, Dr. Ramakumar, for your time, for sharing these slides and having these high quality discussions and sharing your personal opinion about how tribology has helped you to achieve what you have achieved today. And also thanks to the entire Indian Oil Corporation Limited Tribology Group, Dr. Ajay, who was facilitated this for participation of his colleagues here. And thanks to Dr. Bijway as well for being there. With this, we will conclude the session. And the next week, the Tuesday for Tribology, we will have a topic on additive manufacturing and tribology. And we'll have Dr. Anand from General Electrics who will be talking about this on this topic. If you guys want to participate in that, please subscribe for the YouTube channel, Ducom Tribology, and have notifications on this upcoming part. With this, I would like to conclude. Thank you once again, Dr. Ramakumar. Take care.
Thank you. Thank you very much. Thanks for this opportunity.